Welcome to our second lecture on drawing in ENGG1003. Our topics today, we're going to have a general discussion on the use of different types of drawings, and then we're going to take a look at lines. Lines have meaning, and we have different styles of line to convey different kinds of meaning, so we'll talk about that. Now, what I want to bring out, though, today is that this is going to be a bit disjointed. I had wanted to show you the drawings on samples of full-size drawings, and with the cameras that I have, the contrast situation just does not work. So I'm going to try to use a drawing tablet, but this is complicated by the fact that it would really be nice if I had two HDMI ports on my laptop. I don't, or an extra display port. So I'm trying to use my tablet. And so I'm going to have to constantly stop the video and reset, restart, and then, we'll talk about this, that, and the other thing, and go from there. So my apologies if this is a bit frustrating this time, but I haven't found a better way to do it. So I'm going with what I have. So these are what things we're going to be talking about. So one of the drawings, what are they used for? Point blank, drawings are used as a more efficient means of communication. You've all heard the expression, picture is worth 1,000 words. For some pictures, that might be a bargain. But when you start looking at engineering drawings and what you can show on an engineering, if you tried to put that in writing, I dare say it would be impossible. You couldn't put something in writing and have somebody read your work sufficiently and be able to recreate, say, the drawing or the part. Actually build it. So drawings are an invaluable means of communication, and the goal in drawings is to be efficient. All right, we want to communicate everything we need to communicate, not too much so we overwhelm the person and they make mistakes. We want to present it in a neat and efficient way so that we can accomplish whatever it is we want to accomplish. So what are some types of drawings? In terms of the ideas we're going to be working with, and something that most of you will probably come to interact with, and maybe you already have, are architectural drawings. And architectural drawings are a form of engineering drawing. And when you get down to it, a lot of the concepts we want to teach are all shown in architectural drawings. So I'm going to show you some drawings, and we'll just take a look at them, have a brief discussion. I wanted to show you my house because my home, I was my own general contractor. I designed it, drew it up, built it, but I don't actually have all the drawings, and because of the size of my house and the camera limitations, I really can't do that. So I'm not going to do it. However, I will show you a full set of engineering drawings I did. I designed when I was much younger. I told you last time I actually did 2 years of architecture, actually back in high school. It was fun. It's always been an artistic release for me, actually. But we had a family, there was an acquaintance, and so I actually, they had bought some land. We were living in Illinois at the time. They had bought some land for a small vacation home in Wisconsin, and I was asked to design a home. So, which then they took to a builder and looked at building it. I have really no idea if they ever wound up building it or not, but it does give a set of complete architectural plans that we can talk about. So I'm going to take a break here, set up for starting to show those drawings, and I'll be right back. All right, we're going to start up now. And so the person that I drew this for was actually a social studies teacher that I had back in my junior year of high school. Really nice person, and so they were really excited to be able to build a vacation home, and I believe his brother was his builder. Anyway, so I had the chance to design this, and so I just want to show you. So here's the first view we have. This is actually, they had gone, and so the house is built on quite a slope, and so they wanted to basically have a house that would have you drive into the basement and live on the upper floor. House only about 1,200 square feet, so it wouldn't be very big. And so here's the first drawing I'm just going to show you. So here we have all these lines showing the topography as picture the land sloping downhill. So here you can see the outline of the house. So here we had the driveway coming in. This is out sort of in the middle of nowhere, Wisconsin. So gravel drive leading in. And so then the idea is they would be having earth moving equipment through here, flattening this portion out. And so you'd have a steep slope to allow a walkout basement. And as is typical with many people, they relative to the house, this was all forested, so they are taking out lots and lots of trees to have a view, and it's going downhill, and apparently in the distance there's mountains and stuff, and it's really pretty, so be it. Okay, so this is a topography drawing, all right? And if you look at what this is looking as if the land's on a slope, but it's as if we were looking at it, what do we see straight down? Okay, this would be an orthographic projection. We'll talk more about that in a bit. Okay, let's move on to the next drawing. And so here's the floor plan of the house. And so the house is small, so I could fit it in here, but little bit of contrast issue over there, so for that I apologize. Anyway, so what happened, basically they were driving in under here, and so there was stairs would come up, and so I did this in 1979, before the time of open concept. So if you look at this, I was ahead of the curve here. And in terms of the house, what they told me is at the time, I think they wanted 1,500 square feet or less on the main floor. They just wanted 2 bedrooms. They didn't have any kids. So they were kind of like the modernish concept, which at the time still was often very cut up in that day. And so other than that, they just said, show us what you had. They really didn't know what they wanted. They knew about the size they wanted or less, but outside of that, it was all open. So you'd come up, and so there was a back. So you had woods back here. So there's a deck. There's a door in. Here's the kitchen. You could go in. Here's a laundry room with a coat closet. So open concept kitchen looking out to the fireplace. Lots of windows all around. They would have a place where they could set their sofa set or whatever. The idea is they would just eat at a counter. They wanted a greenhouse. So what we have are 2 bedrooms looking out onto a greenhouse, and then opening in onto this big deck looking out to the mountains out in the distance. So there's the floor plan. Now if you look at this floor plan, you see lots of different kinds of lines here. So notice here we have, if you looked at that, there's a little S there, and then this is a dotted line going here to a circle with an X through it, and going off to another S. Okay, the dotted line, that shows this is a switch, the S is the switch, and it's dotted line to what it's controlling. And the circle with an X through it, that's a symbol for a light. All right, so you can see there's other switches. We have lights over the fireplace. Then you see this circle here with 2 lines through it. That's the symbol for an electrical outlet, and they're all around. Okay, and if you look through here, refrigerator, a stove with an oven beneath. It's hard to see, but there's a sink there, and over here is a dishwasher, the usual types of things. All right. Now then you'll also notice that we have our dimension lines are all out here. Okay. And so what you have is you have an extension line coming out. And so if you were to look here, there'd be a space between this line and the line of the building. Okay. Nothing that's not real. Extension lines aren't real. They're just for the purpose of showing getting to the dimensions. If it's not If it's not part of the body, it's not connected to the body. So anyway, you come out, and so basically we came about a quarter inch past the nearest obstruction, and then you can see in this case, so then we have measuring from here to, this would be to the center of that window. This is to the, so this, here we have the fireplace, and so what a floor plan is that it's at a 4-foot level. It's a slice through the building, looking down at what you see. So this is the cross hatching. That's from basically cutting it, so that you're seeing the surface of all the cement or brick or whatever that's there. And so you can see this is the outer covering on the fireplace. Anyway, so you can see the size of the fireplace there, so on and so forth. Then there's summary dimensions, and then a big dimension here going out to the edge of the greenhouse. So you can see there's dimension lines, there's object lines, various symbols. We have dotted lines to show things that are connected. Then here we have, out here, this is an auxiliary structure. So it's attached to the building, but it's different constructions. So we have, this is done as dotted lines as well. So different kinds of lines to communicate different kinds of things. Now, if you notice, to the extent possible, the dimensions are outside. We try to not put too much inside, because then the dimensions can be hard to find, and it could also make the drawing hard to discern. Okay, so there's the floor plan. It's I think it's 38 feet and probably about 38 feet out to here. So it's about, and then you have these cutouts here. So it's about 1,500 square feet. It's not very big. It's designed for a couple that would have guests out in the country. All right, so that's drawing 2. We'll go to drawing 3 in this design. Maybe. I'm going to pause and figure out what it takes to make this go up. All right, we're back again. So this is considered the front. The front. So here you had the greenhouse, which has skylights. So lots of windows all around the greenhouse. That makes sense. These are the windows into the bedrooms. Bottom is a field stone on cement. And here you can see this porch, which with globe bulbs going all around at the various corners. Field stone covering on the fireplace. As I mentioned, the fireplace had a cladding on the outside, which you could see in the other drawing. And so then here is this, it's basically a single gable roof going up and going back. I think it looks kind of cool. It's been 41 years, but I think if you were to see it today, it still would reasonably fit in. Okay, we'll go on to the next drawing. And this is the left side of the house. And in architecture, rather than call it the side, they call it the elevation. And so basically this is just a flat view looking at what you would see from the house. There's no perspective. Nothing's going off to a point in space, like two railroad lines that meet at some point. All right. So fireplace is there, and here's the chimney on the far side. So they can come in. You can see the underneath the ground dotted lines. So these are hidden lines in this case, is what these dotted lines mean, showing the foundation. Here, so they have a garage they can drive into and take their groceries upstairs, as it were. And you can see the house from the side. Here's the porch added on the side, then we have the other porch up here. So that's the side view. Now we'll take a look at another side view, I believe. Yep, this is on the right side. All right, so here's the fireplace, and you can see that in the day you didn't have computers to draw everything, so we put a little bit of field stone, or I did, in the drawing to show what that would look like, but then it's like, use your imagination to get the rest of the idea. So here likewise we had siding on the house. Didn't to try to draw that in would be a nightmare. With a computer, it's a lot easier. Okay. This break here, this and the left side were all on one piece of paper, so you're seeing the left side start to show through on the camera. Deal with it. All right, so again, so this is, if you're making a house, you need to have the site plan. We saw that first. You need a floor plan. This would have two floor plans. There's a basement. You need to have, then on the outside, a front view, a side view, the side views, the back view, showing the details of what you want. So next drawing should be the back. So here it is in the back. So great big door to walk through, and they can see back up the hill. So you can see the windows. Here's the foundation work that's all in. A few dimensions on how it all fits together. So mentioning what kind of shingles to use, so on and so forth. So there's the rear side. Now I'll note for really elaborate complex homes, it would not be too unusual to actually have a top-down view showing all the intricacies of the roof. So more drawings of what it would take to be able to get a quote and build this house. So here I have the basement view, so they could drive into their garage. And basically what they wanted down here was just a place to store stuff. Was not terribly functional space. But they had a utility room that would be coming in here. And basically storage. So in the winter they could put their the outdoor porch furniture inside, stuff like that. So there we have that. Now, so to build a house, then here we have all the support structure. The civil engineers could probably discuss this in far greater detail, but anyway, I drew all of this in. But this was with more classic, so these would be, not sure how long these are, but they'd be 2 by something or others. So it looks like we had a composite beam going across both of these places. And when I did this, I had to do all of the research and get it all checked by an architect to make sure I had all my numbers right. And so you can see how here's the joist coming across. Then we go over to another one, and they overlap there over the beam. We have the center stabilizers that are all in here. Okay, here we're having a bulkhead to make place for the fireplace. All things that got to know how to build a house. So that shows how to lay all that out. So, and if you look at what that was, so what was that drawing? That was a section through the house cutting off the main floor so you could see the supports. Now, here's another section. So this is showing a typical wall, and you notice it says rear BB, so there would be a point on the drawing where it shows where I'm doing this cut through. And this shows the, so this is a section basically through the house, about 10 feet in or so. And you can see all of the roof beams, lays out how the roof is to be done. All of the parts that go into making up that wall are listed. Here it shows the detail of, here's the floor joist coming in and everything laid out so that whoever builds this doesn't have room to be creative. And you'll notice just all the details in here. So we have how it is to be filled up to putting in this concrete floor. Here's the foundation wall. Notice there's a little indentation down here. It's a key lock so that you don't want this thing to just slip off. With all the ground here, it wouldn't slip this way. If you don't have that key, this wall literally could, over time, slide off the foundation and collapse. That keeps it in. So all the little details shown. Here was another one. This would be probably AA. So this would be off the back side where because the ground was not deep enough. We didn't take it all the way down for the foundation to go all the way, so this would be part off the back side, so it's a little different. So we just showed that how that was done, and same ideas. There's the picture of the roof shown. I can't read it. I have the original drawings that are very readable, but it's just very hard to get it to show. All right, here's the roofing plan. So the main support beams. I still remember all the work just to having to find out what the loadings had to be, and these were all laminated beams. So it's kind of would have looked a bit like a post and beam at the roof. So you'd have these massive beams that if they looked at the roof they would have seen, and the specifications called then for wood slats to go basically to finish off the roof, not drywall. So it'd been really, really pretty. The idea was, there's the fireplace, was inside. This was going to be a poor man's post and beam type house and have a very ski lodgy feel. That was another thing they wanted. And I think I got pretty close. Not bad for, 1979, a 17-year-old. And more details. So there's a fireplace. I remember learning all the gruesome details it took to design a fireplace and draw it. And everything here had to be checked by an... this is a full design. And everything had to be checked by an architect that it was correct, or a structural engineer. Somebody at my father's office took care of that. Anyway, I remember who, I just don't remember what his field of engineering was. Anyway, so here's all the details of what it takes to build that fireplace. Okay? So imagine trying to put this in words. You couldn't do it. It would be stunning to see the effort. But here you see the fireplace, so it's kind of tall, wood burning. Here's a little flap for all the ashes to be pushed down. Then you can see I show ashes being gathered down here. All sorts of fun details. This is a symbol for various aggregate, blah, blah, blah. Here's the field stone attached to the fireplace. This would be brick. This would be concrete, or concrete block, with what that would be. Anyway, and then there would be a door down here to open up and take out the ashes. So there's the little door to go where all the ashes go down. And here's the detail for the stairs, and this was all to code. So they very specific. The size, spacing, rise, run, all that had to be done by code. And then in here we have this is the kitchen elevation for the people building the kitchen. So doing all the cabinetry. So there's the dishwasher. Here you can see there's the stove, cooktop, oven below. So, some of the details that are there. All right, and one last picture. So I had to specify there are various details about all things that are in the room. The vault to the ceiling, the type of finish, details for every room. And you'll see there's these little circles with numbers here. That references to some detail I'm trying to describe here. A window schedule, so I had to pick out all the windows. So this is all the models of all the windows, all the various sizes and information, and likewise on all the doors. All the information, the schedules, then so the builder can order those parts and make it happen. So it's not a drawing, but that's part of the drawing. Communicating the information, in this case in a tabular form. This is the most effective way of doing that. Rather than writing all this detail, we just put a reference, and then it just all went to these tables here. And that was sufficient to label this house to be built. Don't know if it was ever built. I often wanted to get a hold of Mr. Bennett and find out if he actually went and did it. And he was so happy he paid me for it. So, and yeah, and his brother also asserted that it was a completely fine set of plans. So the kinds of things we're doing are going to be very similar. There's one more drawing to this house. I did a perspective drawing, and I have no idea where it is. But it's been 41 years, so that's okay. So that's our architectural drawings. Now, this is the old way of doing it. Now, I mentioned last time that, so what we had as we got into the 80s, really, AutoCAD started becoming which was basically, AutoCAD basically did the same thing you saw here. You just, line by line, you built up what you wanted to draw, house or whatever, parts. And then over time, the world moved ahead, and we started to have object-oriented 2D design software. And I actually have an architectural package that I use for grins. And so I'll show you something like that. And then let's just say the next evolution of that was solid modeling, where you're designing everything basically in isometric and 3D. And then, but when you go to build it, then you can break it all down into plans like we see here. Okay? So,